The last contribution we have is controlling data in Gaia-X, utilizing policy as code for product carbon footprint sharing and estimation. So, last but not least, let us welcome Paul Weißenbach, lead cloud engineer at Posedio. I guess it's German, huh?
Yeah, it's welcome. German. We're from Vienna. Thank you. Let me get here. So I'm Paul Weißenbach. I work as a cloud engineer at a small company. This company is partner in the Gigant project. And in this project, we have a use case where a couple of participants share data, and they're manufacturing companies. There is one that is a tool manufacturer, there's a machine manufacturer, there's steel producers, plastic suppliers, and simulation experts. And they all want to work together to help engineers create products with a lower carbon footprint. And what we think all these companies need to share data and then also provide services to each other and to other companies. So this sharing of this data and how to control the data from the perspective of each participant is what my talk here is going to be about. And I can warn you a bit, it's going to be rather technical. I will show some code. But first, I go into the first part of my use case, which is the basic sharing of data. Then I will explain policy and policy as code. It is slightly different what Yasir showed today, but we'll get to that. Then I will go into what policy as code is for a service from one company, what's it like for a data space service, and what we can get out of it if we try to provide it to multiple data spaces. And while going through that, I'll show a couple of different policies. So for example, here I go into access policies, admission policies, content policies, and what I call sharing policies. And this will take us a bit. I show some code. I hope you can follow it. If not, just come to me later and I'll explain every code snippet I have for you. And then at the end, I'll go into the second part of the use case, which is about this footprint estimations. So there's all these companies working together to get an estimation for a use case. And I use this use case to introduce you to usage policies. And I'll finish up with a bit of how we can manage these policies. Okay, so let's get into it. So basically what we want to have here, we want to provide a service where an engineer, if he designs the tools, like he can use different materials, and he wants to, and for his purposes, there might be multiple materials suitable, and we want him to be able to choose the one that has the lowest environmental impact, right? So we provide some kind of, so this is a wireframe, so we provide some kind of search mechanism where he can look up and search for it, and then he sees how much CO2 equivalent this material has. We also want to store this information reliable, so when he goes back in the future, when he looks back, he also still has this information available, so he can explain his decisions. But this is from the perspective of the data consumer. From the data provider, we want to give them a control who can access the data. Because if you can imagine, some of this information is rather sensitive. Companies don't want to compare to each other in case of environmental constraints. So we want to give the data producer a lot of control how to do this. And the approach you use is policy as code. So I show here a little wireframe. And the actual service doesn't have a UI, but I'll get to that in a second. So briefly about policies. I basically follow this definition. So when I talk about policies right now, it's this plan that is agreed to by a group of people, right? And this group of people, in our case, it's the participants, but in the definition, it could be everything. So what I like to say, I'm an engineer myself. I often forget that this all has to be, I like to do programming. I often forget that all these things have to do something, and the same is for policies. They're not an end in themselves. So the policy should reflect the goals of the participants. And I like this structure of you think about your goals, what instruments you would want to use, and what's the implementation look like, so you can align that. So now I have this example here. You want to protect your intellectual property. And then the instrument you can use is coercion, which you could implement with role-based access policy, for example. Or another example, using coercion as an instrument, your goal is to provide historical data, reliable, so the implementation is basically you forbid deletion. That's the implementation. But it doesn't need to be coercion. You can also think about something like your goal is to increase data quality, and then you can offer discount on audits, for example, to motivate people to increase the quality. No. So when you think about putting this policy into executable code, so for example, this is nothing new. So as a programmer, we all have written some validation or putting rules in our services. And for example, this one is when if you only want to give someone access to a footprint, if it's a customer and the customer has this product. And the different policy as code approach makes is that we separate out this logic that checks this policy part out from the service itself and put it in something like, which I call here the policy evaluation, right? Yeah, I have an animation. So this couples the policy from the application itself. So Pierre mentioned it today, what we usually refer to the things that the service then becomes the policy enforcement point, and the policy evaluation is the policy decision points. And this gives us a couple of benefits. For example, we can reuse the same policy from different services. Example here is we have the steel provider has some service that he provides process metrics to his customers, or QA test services where a customer can access the tests of the products he bought. Another benefit is that this gives you a central decision log. So you can check all the decisions that had happened by this policy evaluation service. Talking about implementing policies, there's many different implementation possibles. I think in Gaia-X there are two domain-specific languages especially interesting to do so. One is the ODRL, which Yasser already explained a lot, and the other one is Rego, which is language for an open source tool called Open Policy Agency. And this is more coming from a background as a cloud engineer. This is something we see in cloud infrastructure a lot. So this is where I feel comfortable, so my examples will mostly be with Rego. So if you look at this service that calls the policy evaluation service, it basically gives him information. It tells it what policy it wants to be evaluated, and it gives him input. In this case, information about the customer and also the product it wants information from. Then the policy evaluation service itself has the policy stored there and some data, and then it evaluates it. It gives back the service something like an information about allow, true, or false. And if we look at an example policy, it can look like this. So the first line just defines the package, basically a namespace for the policy, which you can use to refer to it. Then what we do here, which is already a bit advanced, we import some functionality from another place in this policy system. Like in this case, we import this isCustomer function that comes from a customer relationship management package, so we don't have to write them ourselves. Then the policy itself tells you allow or false, and the default thing is false. So all the conditions down below, this allow if, all the conditions in there need to be true in order to become the allow to be true. So and here it is this isCustomer function, and the second part is a bit more complicated. It checks if the product that's going to be requested is in some list of bought products from that respective customer. Yeah, so I hope you get an idea how this policy looks like, and what we already can do, and this is actually one of them, we can write access policies, right? And what we can do is we restrict who can access a footprint. We can do it based on multiple things. So it's relatively small, I think. I hope you can read it. So that, for example, we can use just the PCF data itself. So we can make a policy that is just on the data. For example, is if we mark a footprint as public, everyone has access to it. And there's no mention of any input or user in this. But we can also go the other way around. We can just make the access dependent on the user who accesses it. Like we could give access to an admin to everything, which a data provider probably doesn't want, because why should he give access to the admin? But we can also build a bit more complicated things that are based on both. So this is the third example here. We can check, for example, if the status of this footprint is a draft, then the user needs to have either the role PCF manager or PCF reviewer, and then he can see the things. And you can also do silly things with this policies. You can basically just whitelist specific users, but I would not recommend that. Then, so what I'm talking here is a bit of, if you look at the design of a service, it looks like this. Like there's a service, the policy evaluation, and you have some kind of place where you store the customer information. And this is all in the realm of this one company, this data provider. But what we want to do, we want to provide a service for a data space. So this service then, the PCF service and the policy evaluation is then in the realm of someone else. And this link between that and the steel provider is probably something the steel provider doesn't want. So, and this is where we could do something like that the steel provider has some kind of proof service that issues a verified credential, for example, that actually is a proof that the customer bought the product. This then we can use to write the policy. So this is just another allow policy. And what we do in this policy, we have a little extension that verifies the proof of transaction. So we know that this is correct. Then we check the proof if the buyer is really the one who wants to access the product, and the product is the one that it's requested. Okay. So putting this together, so this policy layer allows us to do two different things. Like we can just, the first thing to mention, we can put external information beforehand in this policy evaluation system. Then you have the first rule. Then what I just mentioned with the verifiable credentials. This is the one with the checkbox, which is nice. Or you could also do with this thing, you can call out to another service. So every time, so this looks like this, so every time someone wants to access a PDF, we would do a network call to the service from the steel provider that tells us if this customer has brought this product, and if so, we let it access. But this has a lot of, this doing a network call and introducing the latency of it while having access policies is bad, because what do you do if hundreds of footprints are accessed at the same time? Then you have to do hundreds of network calls. It takes a lot of time, and you don't want that. So I think using these verified credentials is a nice way that gives you speed and gives you speed. So what do we do if we want to address multiple data spaces? So this carbon footprint I think it's of a universal interest. It's not just in the manufacturing domain, it's also in the logistics domains. And this is also, I think, so for example, we have here in the manufacturing, we have all these companies, these participants I mentioned earlier, and also federator. That gives you a catalog, for example, has IDM system and maybe a contracting service. And then the logistics data space probably is the same thing. And if you compare it to the things down below, as in the center is this product carbon footprint sharing service, down below you can also address the outside world of Gaia-X, which doesn't give you the things, right? You can do custom contracts, but then you have to implement them yourself, right? Or you can have, as in this, you can have your own subscriber model, but then you have to implement that yourself. So having this opportunity to go for one data space and then writing rules for pretty much all the Gaia-X data spaces is really nice. Okay. So, and it's really nice from a technical perspective, but it also gives you benefits that you can rely on these data spaces. And this is where admission policies come into. You want to decide who uses your service, and what you can do then, you can use the data space infrastructure to delegate this decision to. So you can say, everyone in a specific data space is allowed to use my service. And this can work different ways. So for this Eupro-Grant data space, we check if the user has a legal participant, and it's verified, and then we check if that participant is in a data space by going to its catalog, check if we find the legal participant there, and if so, we allow it to use our service. But you can also use the identity management system. So you can check if the user provides a token from the identity management system from that data space. Or you can do, I don't know, you can say anyone with a Gaia-X compliant self-description can use that service, right? So what we have now is we allow users to use the services. And what they can do is they can publish these footprints. And now we use policies to control how these policies looks like. So for example, we can check a field it's set. And this works a bit differently than the policies I introduced earlier. So this is this allow, and then we don't want to have each rule evaluated alone, and if it's true, we want to allow it. We want all the rules we have to apply, and if one is broken, if one is one is, how do you say that? One fails to validate, we want the whole thing to fail. And we do this here by this allow if count errors. So we have rules that produce errors, and if there's no error, we allow it. And the example here is we look at the footprint excluding biogenics. That needs to be bigger or equal to 0. That needs to be bigger than 0. If it's smaller than 0, we provide an error, right, and give it an error message back. Or if you want the footprint to be audited, we can write the rule that if it's not audited, it provides an error that it needs to be audited. And I think the interesting thing here is that you have different participants here that want to write these rules. You have the one providing the service administration, but you also have the data provider who wants to restrict it. So for example, we as the service administration want to restrict this excluding biogenic, right? But then the data provider itself wants to restrict, also in case the data provider as a company wants to restrict its employees what kind of product carbon footprints it can publish. Like it can say that it needs to be audited. Or it can even go a bit further and say it needs to be audited in the last 6 months. And this is the policies down there. So since we talked about creating, publishing policies, it's also interesting to talk about how do we delete them. And we differentiate there a bit between deletion and yanking. And one thing is deleting removes the thing completely, and yanking is just, it removes it from indexes and catalogs, but preserves the data and the history of it. So if an engineer relies on that, relies on it and uses it in his analysis, and it has to show it, so it still can go back. But the company is capable to kind of message that we have a new value here. Okay, and for deletion, it's the same. We want all conditions to be true, and the one here from the service administration is basically it needs to be published at least 20 years ago, right? So, and if not, we tell you cannot delete it. But the data provider itself can then restrict it further, right? This is the second rule, can say, okay, it needs to be end of life plus 10 years, but then the data provider also needs to maintain this end of life date. Yeah. You can also use this for organizational policies. Like you can say, not everyone in my company is allowed to delete this PCF. So you can say the user who wants to delete it needs to have this PCF manager role. So you have a bit of a role-based access control there. Or you can just prevent the deletion completely if you want. So since we don't have any UI for this service, we want to rely on the catalog of the data spaces we use. And in order to do so, if a data provider publishes a PCF, we generate a Gaia-X data resource, and we want to fill out the field in it for the policy. And the spec mentions like Rego and ODRL, and this is the place where I think Rego is not really usable for it, and ODRL is the thing to use. And I was also thinking of this policy field, it's better to think of it that the policy is more of a statement of intent. And then it is used for filtering in the catalog or for contracting. Yeah. So once we have this data resource there, the data consumer can search for it in the catalog, and then if he gets a link back, he can go to our service and read the PCF. But this does not need to be, I'm not sure. So open digital rights length, I have this pretty much the same example that Yassi used earlier. So it's, we put on the data offer, we put a ODL offering, and then we can restrict it, in this case it's a permission, and the permission is then constrained to some region, I think so. So this is what we do. Since I'm from a Rigo background, for me it's easier to write Rigo policies. So what we do is we kind of automate the generation of these policies, and that works because the output of a Rigo policy can just be JSON, and the Rigo policy is just JSON linked data, which is JSON. So we make it a bit easier for us to write policies, and the example here is the permissions. This permissions field in the URLs should contain an array with the action share. The assigner is the default assigner. If this PCF is set that it is allowed to be shared, and the license is, for example, CC BY. So what this whole thing does, it generates this whole ODL policy, and we can put it in this data resource and then publish it to the catalog. And I think this is really a matter of taste. If you like to write ODL, you can just also put it there. You can use Rego. What we did, we have some little helpers to make it. Let's see there. Makes it, in my eyes, easier to write, a bit more succinct. Yeah. So the example here is like, instead of having to write this whole object with the left operand, operate the right operand, we abbreviate it in a little function that just says country in sub, and then you add the list. But it's a matter of taste. Then the other thing is, now I talked about the policies we put on the data resource, but the policies they don't necessarily have to do anything with us. So for example, the data provider can just add a policy offer to catalog. The data consumer then sees that and gets an agreement with a contract service or the contracting service from the federator. But if the data consumer then wants to access the data, we should respect this agreement. And this is where the last part of the access policies comes into play. This is where we implement that these agreements should be honored. So the first example is we say that if the agreement is not backlisted, because sometimes agreements are misused, we verify the agreement, and then we have a little helper which is that evaluates the ODRL. In this case, it asks, does it have the read permission? The input product URL is the target in the ODRL permission, then the agreement itself, and then it provides the legal participant that's needed in the agreement. But this is when you have an agreement. We also think it is nice that if this policy offer restricts the geographic area, for example, then it's probably not necessary that the data consumer needs to contract, get an agreement, and provide us the agreement. We can just look at the legal participant, see if he matches or has the rights in the offer, and then allow access without going through the contract negotiation. And this is the second part down there, which is just evaluates the ODL policy, and if it using the policy offer, and if it evaluates to true, just allow it. Right. And this is basically it about the sharing of data. So it's a lot of policies just for storing data somewhere and retrieving it, right? But things can get a bit more complicated, and this is where the second part of my use case comes in. It's about estimating, right? And there, we want to allow an engineer to have a simple interface where he can input his design. In this case here, he selects the material, he uploads a 3D model of his design with probably some manufacturer information attached. He says what quantity it wants, and then requests an estimation. So Behind that, there are all these companies, and it's a lot more complicated, and it is rather complex. So there's different ways to model this, but if you look at the Gaia-X description, so we have a service offering that's provided by the estimation service. That depends on a service offering that is from a tool manufacturer. That itself uses data from a data resource that's probably exposed through our service we discussed earlier, that has, I don't know, the copyright and the production is something, and a lot more. Then back to the top, there's a service that also probably uses data from our services, but it also depends on other service offerings from the machine manufacturer or from a processing, and they all have to work together. And in this example, this is for writing a policy. I added to all the service offerings a label, and it's for the criteria that all data should be processed and stored in EU or in the European Economic Area. And this is something we potentially we can use to write the policy. So this is now a policy that either the service administration will limit what services are offered through a system, but more interestingly, for a data consumer that can limit what his employees, his engineers, can use the service for. And what I do here is we go through the complete graph of service offerings, as the service offerings and the things between. We select all the service offerings, and then we check if they have the label we want to have with the level we want to have. And if not, we provide an error. And then we have the same thing like before. If there's an error, we just don't allow to use it. And here you can also do things like whitelisting. You can say, oh, this service is not described as good as we want to have, but we allow it anyway. So this is the second rule. Or you can also say, this is a service our engineers want to use, and it fulfills all the other criteria, but we have a bad feeling about it, so blacklist it, right? And there I think this is a quite powerful tool, and this is also brings me to almost the end and talk a bit about how we manage these policies. Since they're all code, we manage them in source code management systems. And I'm working at that alone at the moment, but once you have multiple participant work, you can do nice things like you can code reviews, you can introduce automated testing. If you really care about who did what, you can introduce signed commits. And if you want to provide some transparency, you can just make a public repository. And if you have never seen Git, this is what it looks like if you use Git in the command line. You have a history of the things, and you can see what changes in each step of it. But the plan for the future is also to provide non-developers some basic means to edit something. Like these features like activating and deactivating rules, adding new rules, basic editing. And what I think is, and also seeing the changes of a rule to have some kind of transparency what's happening. What I think is a really powerful feature if you think about designing such a system is to see the decision logs for a rule. So you know this rule has produced this outcome. And what's even further useful is that you can replay these decisions with an edited rule. So you can use your past decisions to anticipate how your changes would look like in the future. Yeah. So, and this also brings me to the end. So policy is code, and all these policies is about to automate policy and develop a rule system aligned with the participant goals, right? This is the challenge. This is also something every software engineer, I think, knows that. And what I think Gaia-X and verifiable credentials bring in a lot of benefits to do that. Like, they bring in a common vocabulary and labels which you can use to write policies. You can benefit from the data spaces you want to address, like for participant and service offering vetting, or you can just use the infrastructure they provide, like a catalog, contracting service, or identity management services. And in general, you can use verifiable credentials to externalize information, so you can go from this company service to a data space service. Well, I think I'm pretty much ahead of time. So thank you, and If you have any questions, please feel free. Yeah.
Thank you very much for the presentation.
Yeah. So go ahead, sorry.
Thank you for the you need to tell me when that's working. So thank you very much for the presentation. I had one question about the policy engine and the link with the verifiable credentials. So how could we envision that the rules expressed in Rego could maybe connected to a wallet so that we can dynamically query additional information to fulfill the execution of the rules?
Yeah, so for now, what is this? This is the service responsible for that. So the service needs to collect all the information and provides it to the policy service. But you can sync it as you could. So also this verifying is a custom extension for the open policy agent. You can think of doing something like that. But then you have to take care of, I think, of your architecture, because it can get, like if you think of call graphs, it might get complicated and you want to restrict it in some way, so the ones who write the policy will not go overboard with it. That's it? Does it answer your questions? Okay.
Thank you so much for your presentation. I'm Masaru Bashi from NTT Data Group, and I found in your presentation the challenges about the multiple data spaces. Actually, I'm also tackling the similar situation, and I'd like to know more detail about your concept or challenges or definition of the pain points and so on. So that I think in your figure there are some central PCF calculating services. And it seems to support the multiple kinds of ecosystems. So I'd like to know more detail about the concept. Thanks so much.
So it's not much a concept. So it's really, oh, we want to use the infrastructure from this data space and then write a policy that uses that one. So it's like I said, oh, we want to use the catalog, then we write the policy that goes to that catalog, checks if the legal participant in there. Mm-hmm. This is from a policy perspective. From a perspective of creating data resources and adding policy, it's a bit more complicated.
Yeah.
There's different catalogs, like the Federated Services catalog, then there's Pontus X, for example, then you have to take care of the different things. Mm-hmm. How there's a bit of a difference there, and we tackle this in the service, not in the policy layer. Mm-hmm. Mm-hmm. But we can, and it's also not, we have, so my colleagues wrote the paper, and I think it's an accepted paper, and I'm a co-author on it, and if you want, I can show you the paper. We have an architecture to do that, and we might just discuss that even further.
Okay, please send me the paper. Yeah.
Can you come to me later?
Yeah. Okay.
Nice. Doesn't look like another question.
Doesn't look like there are more questions, but thanks a lot for the contribution. Especially, I like the example because carbon footprint is a big pain point for a lot of companies, and tracing the whole thing is even more important than it was until now. So,
I hope.
Thanks a lot for that nice example.
Thank you.